parabola. This parabola is an x squared, so it's a vertical parabola. But it's also got this 13 sort of cluttering up the joints. So let's move it over. And I've got a 12y minus 13 then. And it's going to equal x squared minus 2x. And then the space provided for the completion of the square. Again, just did this twice before. 2 divided by 2 squared is a 1. So I'm adding 1 to both sides. This becomes an x minus 1 squared. This over here becomes a 12y minus 12. Well, the standard form of a parabola, at least in the conic sections section that we've been doing, usually has a coefficient in front of the squared term that allows us to be able to identify p and therefore our focus and all these kind of things. So when you have something on this side and a completed square, when you're creating this type of an equation, by the way, which is a vertical parabola, then we need to kind of clean this side up a little bit, and in so doing we will create a denominator here. And the cleaning up process is basically, what can I divide y by to get rid of that 12? We need y to be by itself. And doing that, you can factor out the 12 and then divide, but essentially you're dividing both sides by 12. And your graphing form, as long as you remember you're reducing both of these by 12, you should get a y minus 1 equals 1 over 12 times x minus 1 quantity squared. Okay, we can identify various things here. The vertex is 1, 1, and if you even screw it up, it's 1, 1. But you take from the x, it's the h value and the k value. The p value is 3, where you can find the focus and the directrix. But you don't have to here.